Good evening. In today's class, we are going to discuss about the round robin scheduling algorithm. In the round robin scheduling algorithm, we have one more important parameter called time quantum, which means each and every process should take maximum amount of time in the CPU is said to be given to you. Okay. So here the time quantum is defined as 2 milliseconds. Totally 6 processes given to you. Its arrival time and burst time is also given to you. Now let us see how to draw the Gantt chart. Initially in the Gantt chart, always start from 0. Okay. So at 0, at arrival time 0, you need to check which process get inside the ready queue. Only process P1 is get inside the ready queue. So just assign P1 to the Gantt chart. The total time quantum given allotted is 2 milliseconds. So just process P1, it executes only 2 milliseconds. Okay. After that, P1 should come out. Okay. So now the thing is, during this time interval 0 to 2, you just check what all the other process get inside the ready queue. So at arrival time 1, process P2 get inside the ready queue. Then arrival time 2, process P3 get inside the ready queue. Okay, only 2 processes are there in the ready queue. Now you just check whether your process P1 has completed its burst time or not. Since the time quantum is defined as 2, your process P1 took only 2 milliseconds and remaining 2 milliseconds is there. Okay. Now after filling out this remaining process arrived during the time interval, after this you are supposed to fill process P1, that is the remaining burst time you need to execute at the back of this process P3. Okay. At the end of this process P3 in the ready queue. See, listen. Process P1 start at 0 time interval. Then it takes 2 milliseconds. During this time interval, process P2 and P3 get inside the ready queue. Process P1 has not completed its execution since the burst time is given as 4. So remaining 2 milliseconds is there. So you just put that P1 back to this process P3. Okay. Now this P1 over, you just take this P2 and assign to the CPU. The process P2, the total burst time is given as 5 milliseconds, but the time quantum is 2. So process P2 will take only 2 milliseconds. Okay. So now what happened here? 2 milliseconds means the remaining is said to be 3. Okay. Now between this time interval 2 to 3, you check what are the other process that enter into the ready state. So process P4 will get inside the ready queue. Then process P5 is also get inside the ready queue. Okay. After making this entry in the ready queue, you check whether process P2 has been completed or not. Process P2 has not been completed. So put the remaining process P2 at the back of the P5. Okay. So now this P2 over, you take P3. P3 burst time is given as only 2 milliseconds. So the time quantum is also set to be 2. So it will make 2 milliseconds to execute its process. So at 6, P3 will get out. Okay. You just check in between 4 to 6 what all the other process get inside the ready queue. So only P6 is get inside the ready queue. Okay. You need to check whether process P3 has been completed or not. Yes, P3 has been completed. Since the burst time of the P3 is said to be only 2, the time quantum is also 2. So it gets completed. So you no need to put this P3 at the back of P6. Okay. Now you assign this P1. Okay. Okay. P1 burst time is said to be, remaining time is said to be 2. The time quantum is also 2. So just you take 2 milliseconds. This P1 will get over. Then you make this P4 to assign in the Gantt chart. So P4 is said to be only 1 millisecond. So even though the time quantum is said to be 2, it needs only 1 millisecond for its execution. So P4 will get over. Okay. Then you can make use of this P5 here. P5, the total burst time for P5 is given as 6 milliseconds. Okay. 6 milliseconds. So here what you have to do? Okay. You assign only 2 milliseconds. So remaining 4 milliseconds is there. Okay. So again you have to put this P5 here at the back of the ready queue. Now you assign this P2 here. The P2, the total burst time is set to be 3. You can able to execute only 2 milliseconds as per the time quantum is given to you. So you have to complete the P2 at 2 milliseconds. So remaining P2 you are supposed to put at the back of the ready queue. Then strike out this P2. Then you take this P6. P6 has 3 milliseconds, not 3, 4 milliseconds. Just take 2 milliseconds. Okay, then assign here. Then you put the P6 at the back. So you have to add this each and every process until its total burst time supposed to get completed. Okay. Now what happened? P6 over. Then you take P5. P5, the burst time for P5 is, it will be 2 milliseconds. So it will take 2 and it gets completed. Okay. Then remaining, you just assign this P2. The P2 is said to be only 1 millisecond. So you have to complete the task P2 by 18. Then remaining only P6 is there and the total burst time is said to be 2. So you just assign the P6. So the total completion time is said to be 21. I hope you understood this process. Okay, so again I will explain. So at time interval 0, process P1 get inside the ready queue. Okay, between the time quantum is said to be 2 milliseconds. It takes 2 milliseconds to execute. During this 2 milliseconds, you need to check what all the other process get inside the ready queue. So process P2 and P3 get inside the ready queue. After that, you have to check whether the P1 has been completed or not. P1 has been completed. So you just put the P1 at the back of P3. Then you can take P2, which is there present in the ready queue. So assign 2 time quantum. The total burst time for P2 is 5. So after 2, remaining 3 millisecond is there. So you have to check process P2 in between time interval 2 to 4. So what are the other process in between time interval 2 to 4? Yes, process P4 and P5 that get inside the ready queue. After that, you have to assign this P2 at the back of P5. So like this, the procedure should continue until all the process supposed to get executed in the ready queue. Okay. Thank you.